Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%.
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
With Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have two guests today. I have Toni Pollin. She's an associate professor, University of Maryland School of Medicine. She's a human geneticist and a board-certified genetic counselor. She focuses on diabetes, and there are more kinds than I knew of. I thought there was just type 1 and type 2, but her focus that she wants to talk about today is what's called monogenic diabetes that she'll describe. And she's brought on Emily Moore because Emily and her daughters appear to have this very specific kind of diabetes. So that's who's on the call, and welcome both of you.
Thank you.
Yeah.
Mr. Jacobs, great to be here.
Yeah, so Toni, tell me, you were starting to tell me offline, but tell me a little bit about this other type of diabetes. What is it? What's it about?
Sure. Well, as you said, Richard, you know that there was type 1 and type 2 diabetes. So most people know there are a couple of kind of different broad categories of diabetes. In the 60s and 70s, those types of diabetes were actually known as juvenile diabetes and maturity onset diabetes. So there were the people with juvenile diabetes who were, basically children were thought to have juvenile diabetes. This was kind of an acutely occurring condition where the immune system destroyed the beta cells, and these children had to be on insulin to stay alive. And then there was maturity onset diabetes, which happened in people as they got older. It was influenced by weight and activity level. And those people with maturity onset diabetes often could control the diabetes through lifestyle or oral medications. But there were some very astute physician scientists in probably earlier, but really starting to really talk about it and define it in the 60s and 70s, who said, gee, look, there's this group of, there are some children who have diabetes, but the type of diabetes they have does not look like classical juvenile diabetes, because it seems to be milder. They still can produce insulin, and some of them even respond to the pills that are available for people with type 2 diabetes from a class of drugs called sulfonylureas, which is actually one of now the many classes of drugs for type 2 diabetes. Some actually didn't require treatment and just sort of stayed in the mild range. And so they noticed this, that this sort of peculiar type of diabetes that they thought was, pretty rare, but that kind of shared features of both juvenile, which we now call type 1, and know that it's not just in juveniles also, and type 2, and maturity onset, which we now call type 2, which we actually also know is not just in adults, and that's why the names have changed. But the other very interesting feature about this type of diabetes was that unlike the other types of diabetes, the more common types of diabetes that sort of they cluster in families, which we now know is due to kind of a complex mixture of genetic and environmental factors. These types of diabetes were inherited in what geneticists know of as an autosomal dominant manner, which means that if a person had one of these types of diabetes, then each of their children was showing approximately 50% chance of having the type of diabetes. And it was very consistent with there being one single gene, where a change in one single gene in a given family was responsible for that. And that's similar to other diseases that we know about, like, Huntington disease and sickle cell anemia, but, not really typical of diabetes. But it was in some of these families, and some of the early researchers collected these really large families that showed this. And so that's sort of where it was before. And now, and starting in the 90s, actually there's 3 genes that are responsible for most of these cases, and they were actually discovered in the 1990s. Today, we have tens of genes that seem to be involved, a different gene in different individuals and families. And they actually seem to be a little bit more common than we thought they were, that they may account for, 1% of all diabetes and, and a higher percentage in younger people.
So what does this kind of diabetes have in terms of symptomology and, what's unique about it?
Yeah. So, the tricky part is that in some ways it's not unique. In some ways they look like they have diabetes, but the The things that distinguish it in the 60s and 70s, often what was a tip-off is you had a child who looked like they had an adult onset, or what we now call type 2 diabetes, but the child was lean. So it's like, if you have this kind of lean person, like kind of a classic case is if you have like kind of a lean person who's young, but doesn't show any signs, doesn't have, still has the ability to respond to oral medications, and doesn't have that kind of severe diabetes that requires insulin. That being said, it can be very tricky because what happens is there are all different ways that people are diagnosed with diabetes. So one answer is they can look a lot like anybody else with diabetes. The other answer is sometimes they'll look atypical like that, where you have someone who's young and thin, and yet they have a type of diabetes that's more like the diabetes seen in adults. But what we know is that there are some ways that if we're thinking about it, we can pick up even more cases. So for example, you don't have to be overweight to have monogenic diabetes, but there's a fairly high prevalence of being overweight or obese in our population today. And so we might assume that that an overweight person has type 2 diabetes, when in fact that person, they actually may still have this diabetes due to a single gene. And so what we have, and what the real work that's going on now, and there has been work on this going on at the University of Exeter in England, where they've sort of developed a surveillance system involving nurses who try to work to find these cases, help different clinics find these cases. But there are ways that you can tell them apart. So, for example, if a child comes in, say a 5-year-old, breaks her arm, and she goes to the ER, and they run some standard tests, and maybe they run glucose, which they don't normally do in a 5-year-old, but they might be running just a bunch of things to get the overall health. They may find that the glucose is elevated and the child has no symptoms. So the assumption might be, we're catching this child at a very early stage of type 1 diabetes. We better put them on insulin before they suffer from, some of the more serious symptoms of diabetes. But it turns out that in that case, what's often called incidental hyperglycemia, where the glucose, you just happen to measure it and it happens to be high, that there's a good chance that that's another condition. It's one of the forms of MODY, which is also called glucokinase diabetes, where they have a enzyme deficiency that causes their glucose to be mildly elevated for their whole lives. And in that case, it's usually benign, right? And so, we often diagnose diseases not necessarily by symptoms, but by things we measure. But if we measure glucose, especially in a young person, and their fasting glucose is elevated and there's no symptoms, then we don't usually consider all these, but we need to, because that person might actually have something that doesn't require treatment and in fact won't respond to treatment.
So how will they know that they're sick? I mean, I don't understand. They'll have elevated glucose, and why would they?
Right, they won't. And a lot of these,
if they felt fine, what do they feel?
Yes,
it's different.
Right. So there's different ways, and I'm just trying to separate them. One is, somebody has symptoms of diabetes. They may have one of these forms of diabetes. If somebody presents with symptoms that look like diabetes, things like thirst and excessive urination, then they might go to the doctor and have a diabetes workup. If they're a child, they might be diagnosed with type 1 diabetes and treated with insulin. If they're an adult, they might assume that they have type 2 diabetes. But if they're thinking about monogenic diabetes, then they will look closely and say, if it's a child who they think might have type 1 diabetes, might have autoimmune diabetes, one of the things they can do is first measure these markers that are these antibodies that circulate in most people with type 1 diabetes. And if the person doesn't have those antibodies in their blood through a blood test, then that's a clue that actually what might be causing that is one of these forms of monogenic diabetes. And the forms of monogenic diabetes, the most common forms, encode proteins that are either involved in the development and the function of the insulin-producing beta cells, or in the process that occurs in the beta cells that's catalyzed by an enzyme called glucokinase, where they have an insufficiency of it.
So you mentioned that insulin may not work in these people, maybe would it cause adverse events? Like, what are some of the peculiarities of them physically? What do they feel?
So it depends on the type.
Different?
Yeah, so it depends on the type. So there's one type of diabetes called glucokinase diabetes. And in those cases, they have an insufficiency of an enzyme called glucokinase. And so they actually, when their glucose is just kind of circulating fasting, they don't produce that much insulin. And so their glucose just kind of is just sort of high. When they eat glucose, a meal, when they eat sugar, then their glucokinase is able to work, and they're able to secrete insulin to break down the food. But they're walking around, they just basically have a set point, have a higher set point, everything's shifted up. So it turns out that, first of all, their glucoses tend to be in such a mild range that it's been shown that they don't usually end up with complications. And the other thing that's been shown is if you try to give somebody like that glucose, it'll seem like it's really hard to control their diabetes because their bodies will just adjust and still have the same high glucose. So it won't work, and there could be potentially there could be, problems with trying to give them glucose. The other type of diabetes, and I'm going to have another kind of the second major type of monogenic diabetes. I'm going to have another expert here talk about it a little bit. It's called transcription factor diabetes. It's caused by a mutation in either the HNF1 alpha gene or the HNF4 alpha gene. These genes encode what are called transcription factors that help the pancreatic beta cells to develop and to function and to secrete insulin. Now, they have difficulty secreting insulin. So if you give insulin, it will work. It will lower the blood glucose. But it turns out that if you give them an oral medication, you're treating the actual underlying problem. Where some oral medications, but not all oral medications, help the beta cells to secrete their own insulin. So you're being less invasive, and often with better control. And so, you can imagine that, you get diagnosed with type 1 diabetes, and you either have insulin injections. Now they have an insulin pump, which they didn't used to have. But, going from giving yourself shots every day to finding out, you actually can harness your body's own insulin producing power if you take actually, it turns out, a low dose of an oral medication. And so, whatever the effects there are of insulin, it's certainly less intrusive, it's less expensive, and often confers better control. And so I'm going to just, turn this over now to Emily to talk about her experience.
Yeah, that's what I was going to say. Go ahead, Emily.
Yeah, sure. I mean, I guess I can just explain a little bit about like how my diagnosis occurred, because I think I fit into that pattern that Toni was describing. So when I was diagnosed at 16 with what my doctor, and this was 1986. So it was a while ago. I was diagnosed with what my doctor said was an atypical form of diabetes. He called it MODY. I didn't have any signs or symptoms of diabetes. I was having allergies. And so I went, and as part of this, just the workup that happened when I went to the doctor, they tested my blood sugar, and they were like, oh my God, it's at 290 or something like that. And I was like, okay, because it didn't have any meaning for me because I wasn't embedded in that world. But
it's normally super high, but yeah.
Yeah. So, I worked with the endocrinologist who was just a little ahead of his time. And he said, this in the future, like 20 years from now, there's going to be a lot of different kinds of diabetes that are diagnosed. He was really into research. And he said, but for now, we're just going to say, you have this thing, it's called MODY. It's not really well understood. He advised me to change my diet. At that time, it was like eliminate the sugar, keep exercising, and also prescribe me an oral medication. And that's what I did to manage diabetes, from high school through my 20s. And it generally worked pretty well. And it wasn't until, I always kind of I wonder what this MODY thing is, but there wasn't any information about it ever. And then it wasn't until I got married and had kids, and I started wondering, because by that time I had learned that it was genetic. There was a genetic component. And I started worrying that I could have passed it along to my kids. So I enrolled in 2 studies. One was at the University of Chicago, and the other was Toni's study. And through those, I learned that I had this MODY 3, which is this H1F1A MODY that Toni was describing.
Okay, so, but what did you experience? So they said, you have a high blood sugar level. Did you feel anything? Were you totally fine? I mean, what have you had to do to bring your levels down?
So I just learned, so you have to know that like this was back in the 80s. And so it wasn't so common for people to have, what I did a urine test to check my blood sugar. So I would just have these little test strips. And I was a teenager. I wasn't super good about doing it because it wasn't really clear to me, because I had no physical sensation of like, oh, my blood sugar is high or it's low. I didn't have any of that. until I started taking oral medication. Then sometimes I get these surprise lows and I'd be like, oh, I think I'm having a low. I think I need to eat something. But it was so, this was way before home glucose testing kits and before CGM, certainly. And so there just wasn't a whole lot of data to respond to. So it wasn't something that I really felt. I mean, but I'm also certain that my blood sugar was regularly over 200. I just think it was, rather than being these acute situations that people experience when they're diagnosed with type 1, I was just had this smoldering high blood sugar all the time, I imagine. Wouldn't you think, Toni?
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Yeah. And I mean, I think, and this brings up, a good point, which is that in this particular, this MODY 3, also called HNF1 alpha diabetes, it is like other forms of diabetes, and unlike the glucokinase form I mentioned earlier, it is progressive. And so it's actually fortunate to have it picked up when you're a teenager, and picked it up as Emily describes, incidentally. She was having a workup for something else, and, they found her glucose was high, because having levels that high can start to, cause problems and complications. So being aware then allows you to treat it before it causes you to have these what they call microvascular and macrovascular complications. And so it's useful to know. Often people don't know until they become symptomatic, but there are a lot of people with diabetes that don't know they have it because they're not symptomatic. In fact, it's thought of that of all the now up to 34 million people in the United States who have diabetes, about half of them may not know it.
I mean, what have you been told, Emily, about the consequences of persistently high blood sugar? What have doctors told you? Is it, do you think it's going to cause you all kinds of problems, or?
Well, I mean, it would. I mean, now these days, I'm more knowledgeable because I know that it's MODY, and I have, or I know that it's MODY 3. And so I wear a CGM, and at different points in my lifetime with diabetes, I've taken insulin or oral medication and been on an insulin pump. And so I have the experience of having had, the insulin pump was really beneficial during pregnancy. But I guess my point is I've used those tools to manage the diabetes. So yeah, I've certainly been warned by every endocrinologist I've ever seen that, you need to keep your blood sugar in a tight range. Otherwise you're going to experience the same kind of complications that people who have type 1 diabetes are prone to having, like eye problems with the eyes and heart disease, and, the whole litany of things that comes along with any kind of diabetes, type 1 or type 2.
You wore a CGM for a while, or do you now?
I currently wear a CGM, and I have to say it's I believe I heard in one of your podcasts that you do as well. Am I right?
Yeah, my wife and I wear one. And that's what I was going to ask you, because my profile looks totally different from hers. We eat a meal with, let's say, a bunch of carbs, which we try not to do anymore. Hers will spike up real high and then crash way down. And, she won't feel well when it crashes down, and then it'll come back if, sometimes she has to have one or two things to eat, and then she'll feel better. Mine will, let's say go high and then go down slowly over time. I was going to ask, what's yours? What do your CGM profiles look like? Are they very unusual, or
mine?
Have they been explained to you?
Yeah. I mean, first of all, it's fascinating just to hear that. It's just fascinating to hear that that's your experience too, with you and your wife. I mean, for me, I have sort of the same thing, because I'll say that both of my kids have also been diagnosed with the same form. I did pass it along, unfortunately, to both of our teenage daughters. So each of the three of us wears a CGM. And so we'll eat a meal and be like, oh, look at this. My 14-year-old, sure, blood sugar will be at it's just interesting to see the range of responses we can have to the same meal, to similar exercise patterns. And I can't tell you why they're different. Yeah.
When you guys have the same meal, do you see big differences? What's an example?
Oh, yeah. I mean, well, I'll just take a look at the CGM data from yesterday and see, because I can, because these tools are amazing. Yeah. This is a good example. Last night we had a meal that it had some, usually we eat pretty low carb. Last night we had a higher carb meal that had, rice and some meat and a lot of vegetables. And I know that we all had kind of similar portion sizes, I went above 200 and had a hard time getting my numbers down. I think probably just, who knows, hormones, my age. I don't know. We're all, teenagers, I think, are especially hormonal too. But they, their numbers, the highest they went was, one of them went to 150, one of them went to like 170. So similar meal, similar amount. Diabetes is squirrely, right?
I think all of this raises some really key issues. Richard, you were talking about how kind of you and your wife have different responses to glucose, and we all do. There's so much variation in how our bodies regulate glucose, and I think it's because, glucose, it's such an important thing, that to have energy, the regulation of our energy supply. So it's a complicated pathway. There's lots of different ways it can go wrong. And that's what we know about diabetes. And that's what Emily's unusually prescient physician knew in the 1980s. So I think one of the things this highlights is, to those of us who study the complexity of the genetics of diabetes, here you think this sort of simplifies things. You've got 3 people who have diabetes due to the same exact genetic cause. And yet they're still very different. They're different in age. They're different in the other genetics they have. They share a lot of genetics, but then they also have different genetics. And so one of the reasons many of us are interested in understanding and studying these types of diabetes is that not only can we help people to get treatments that's more tailored to them, but we can sort of start with kind of what you might call the low-hanging fruit, where you do know the cause of it. And you can start to understand those cases, and then you might be able to start to understand the more complex cases better.
Yeah, I guess one thing is, I'm not trying to give advice here, but I've noticed, if my blood sugar is high or my wife's is high, we go for like a 20-minute walk or exercise like in the treadmill or something, even walking, and it brings it down like 20, 30 points. So I guess, in the skeletal muscle, there's a lot of glucose that can be taken up to reduce levels. It's kind of like a quick semi-fix to things.
Oh, yeah, totally. I mean, I can tell you that during the pandemic, we're in the middle of a pandemic, right? And the sort of upside, I guess, to that in terms of diabetes in my family and our experience is that, I have these 2 teenagers in the house. All of us are wearing CGMs. It's a really great opportunity to say, hey, why don't you hop on the exercise bike or go for a walk and watch your numbers and see what you learn. And because we can see when their blood sugar is going high, and then they're here. And so we can have a conversation about it. And it's very easy and natural, and it feels a little perhaps less naggy than it might feel if everybody was out in the real world and we were just texting at them or calling them and saying, hey, why don't you jump on the bike? But it's really helping, I think, them to develop, because they're new to diabetes. They were both diagnosed in the past year. So they're able to really see the cause and effect. And they'll eat and we'll go for a walk, or we'll eat dinner. And if somebody's going high, like I was last night, I'll jump on the bike. But it does, diabetes is not always so straightforward. And so, last night I biked for an hour and nothing changed. So I would say that's probably hormones. Toni can talk about that better than I could. But
yeah, I mean, I guess I was just going to jump in and say, Richard, what I find interesting. So do I understand you? So you all are not you're not diabetic, but you're just interested in monitoring your blood sugar. Is that?
Yeah, we're considered like pre-diabetics. So I'm trying to
pre-diabetic.
Head it off at the pass, and like my wife had gestational diabetes twice, and so she's probably even more prone. So we're trying to make sure that we don't, it doesn't worsen.
Yeah. So this is a great point, because I think it highlights something else too, which is that the prediabetes is sort of in the class, generally when people have prediabetes, it's sort of in the class of kind of being at risk for type 2 diabetes. Sometimes type 2 diabetes is sort of, as I think, mistakenly kind of sometimes referred to as a lifestyle disease. And I think what's been really interesting talking to Emily about it is that really lifestyle plays a role in controlling blood sugar for anybody, whether they have diabetes or prediabetes or don't have diabetes or even have monogenic diabetes. And so, you were talking about how, Richard, that, you take a walk and your glucose goes down 20, but then there will be some people who might take that same walk and it might go down less. And that's where you have this sort of genetics and lifestyle interplay. Some people have diabetes susceptibility factors that are more subtle than the variant that Emily and others have. They may need additional help in addition, to exercising. Some people respond really well. And so I think there's sometimes sort of a tendency to kind of really separate out all these, forms of diabetes. But the bottom line really is that for any condition where there's kind of excess glucose being produced, if the body has the ability to utilize that glucose, then those things can help. Where, the differences are sometimes is, if somebody has type 1 diabetes, if you have type 1 diabetes, for people with the most kind of severe and classic forms of type 1 diabetes, their issue is that they won't produce, eventually, if not treated, they won't produce any insulin. But for many people with different types of diabetes, for type 2, which is really sort of a less well understood sort of web of all different types of diabetes. And then, in monogenic diabetes, as long as you're producing some insulin, then the other ways that you exert control of your glucose levels is through how your body uses it. And that's in that whole area known as, insulin sensitivity or insulin resistance. So you're making, by exercising, you're making your muscles more sensitive, for example, to insulin.
Okay. Well, very good. Toni, what's the best way for people to find out more? I mean, this probably opens people's eyes if they're having, strange high glucose and, they don't just want to say, their doctor may just say, you have diabetes and that's it, but there may be a lot more to the story. Mm-hmm. So what's the way for people to find out more that may be having, mysterious blood sugar problems or issues?
Well, first of all, I did want to mention that there's another more rare type of diabetes. When an infant is diagnosed with diabetes, they used to think that's definitely type 1. They now know that that's usually monogenic, and that about half of those infants have a specific genetic defect where they can actually respond to oral medications better than they respond to insulin. So it's really important in the rare cases of babies who have diabetes to diagnose them. But there are a number of resources. So Emily and I actually, and other patients and providers and researchers have teamed up together. So far, we have kind of a beta of kind of a splash page, but we're going to be we've developed a consortium called MDRAC, which is Monogenic Diabetes Research and Advocacy Consortium. And we have a website, mdrac.org. That has links to some information, and the links it has are to information including the University of Exeter Diabetes Genes page, which is an excellent, very well-developed source for this, the U.S. Monogenic Diabetes Registry at the University of Chicago, and some other clinics. There's a few clinics in this country where people specialize in diagnosing and treating these patients. And a link we need to add soon as we build out the page more is there's a new study that just started at the end of September that I am a co-investigator on. It's a national study involving over a dozen institutions, and it's called the Rare and Atypical Diabetes Network, which has the acronym of RADIANT, because if there's one thing we've all learned in research, then you need to have a good acronym to have a successful research project. This is a project that people can enroll in by going to a website, which is atypicaldiabetesnetwork.org. And what they are trying to do actually is go a step further than trying to diagnose these known forms of monogenic diabetes, which, there really has been a lot of knowledge going on. But if people kind of, find out that they have atypical diabetes, they get genetic testing, and then they don't have a known form, they can enroll in this study where they're trying to look really closely at the whole genome and understand what are the causes of these unusual types of diabetes. But so that's kind of the sites that are available. And what we're trying to do is to identify more resources for people to go to. You can go to, you can see a doctor, or you can, a diabetes doctor, and, just raise the point, bring up some of the resources that are found at these websites. But what we're hoping to do is in the coming months is to really identify where people can go locally to find people people have that have specific expertise in this. But the key is that first you kind of have to recognize it, and then to diagnose it, to know that you have it, then you have to do a genetic test. And the genetic testing involves literally like spell checking the sequences of several genes to see if there's an error in one of them. And the testing is complex. It's getting more streamlined, it's getting less expensive. And so we think that it's going to be easier to diagnose. But I think going to these websites is kind of a good starting point to get some basic information and start to see where you can go to learn more.
Okay, well, very good. We'll end with that. And Toni and Emily, thank you for coming. Thank you very much.
Thank you very much for having us. Take care. Bye-bye.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.